In this video, I will be going over lesson 18, which is about using tree diagrams to find compound probability. Here's our first question, and it says an experiment involves flipping a coin 3 times. Which tree diagram correctly shows the possible outcomes for this experiment? Okay, well, I know looking at all 3 of this first one here is going to be wrong, because if I were to flip a coin heads the first time, heads the second time, I could also flip tails the second time, so I know that is missing. Let's double check this one here. So I have heads, perfect. Heads, tails. I have heads, tails, heads, tails, tails. This is looking good. This last one here, though, if I were to flip heads the first time, that means I could either flip heads or tails the second time. So this last one is going to be out, which means that this center one here is the one that we want. So we're checking to make sure that our heads and tails are alternating all the way down, even from here as well. Our next question says an experiment consists of rolling a dice and flipping a coin. The following is an incomplete tree diagram that represents part of the experiment. What should be done to complete the tree diagram? So this first part represents rolling a dice, right? Those 1 through 6 are my different options when I roll my dice. Say I were to roll a 2. When I flip my coin, I could either land on heads or tails. If I were to roll a 3, I could either land on heads or tails. So I need to add branches that have either that have heads and tails attached to it. So B obviously is not correct. And D is also not correct. Between A and C, we need to read these carefully. So A's branches should be added from each number to either H or T. Branches should be added from each number to both heads and tails. So C is correct here. We want to add branches to each of the numbers that go to both heads or tails, not just one or the other. Our next question says an experiment involves flipping a coin 3 times. We saw this tree diagram already. Which options are possible outcomes of the experiment? Okay, this one's kind of, I don't really know what they were going for here, but all of these that have only 2 options, all of those are wrong because I'm flipping 3 coins, which means I should have 3 different outcomes. So all of these that have 3 different letters, those are the ones that are correct. If they have 2 letters, they're missing a coin flip, so those ones are incorrect. Our next question says the following consists of rolling a dice and then flipping a coin. So here order is important. Okay, my number should come first and then my heads or tails should come second, because I'm first rolling my dice and then flipping my coin, which means that this one down here and this one right here, where there's not even a number, those are both wrong. I could roll a 6 and then land on tails. I could roll a 4 and land on heads. I could never roll a 7, however. 7 is not a part of my tree diagram. It goes up to 6. 7 I will never be able to get to. And I could also roll a 2 and then land on tails. Our next question, we have that same flipping 3 coins tree diagram, but we want to know what's the probability of getting exactly 2 tails. So I'm going to go through and kind of highlight the branches where I see I'm getting 2 tails. So that's 1, right? I could do heads, tails, and tails. Here I could do tails, head, tails. I could do tails, tails, and head. And that's about it. If I double check and I'm looking through all of them, I don't see any other options where I'm getting exactly 2. I can only have 2, which means I have a 3 out of 8 chance. And the 8, if I were to look at my very last column, add up how many heads and tails I see here. So I have 1, 2, 3, 4, 5, 6, 7, 8. That represents my total number of outcomes, which is where that 8 is coming from. So probability of getting exactly 2 tails here is going to be 3 over 8. Our next question says an experiment consists of rolling a dice and then flipping a coin. The following tree diagram shows the possible outcomes. What is the probability of rolling an even number or flipping a tails? Okay, so any of these options that include an even number, which would be this 2 heads or tails, 4 heads or tails, and then 6 heads or tails, all of these count because I can either flip an even number or I could flip a tail. It doesn't matter which one happens. I could roll a 5, and as long as I flip that tail, it still counts because of that word or. So here, even if I were to land on an odd number, as long as I'm flipping that tail, I'm good. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different branches out of the 12 total that I have. If I go through and count all the different the outer edges, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 total. 9 over 12 will simplify to 3 over 4. So this means I have a 3 out of 4 chance of rolling an even number or flipping a tails. All right, and that is it for lesson 18. If you have any other questions on the tree diagrams, please let me know.